In this video, we'll discuss angles and angle measures. Now, when we talk about an angle, we're talking about the amount of rotation between two rays that have a common vertex. And we're going to sketch this by having a point with two rays coming from it. Now, we can label this in three different ways. We can either use the angle with the vertex, that's only if one angle exists. We could use the angle with 2 points in the vertex, where the vertex is always in the middle, or we can use the angle with a number if the angles are numbered. So there are multiple ways we can potentially label our angles. So in this case, if we look at this example, there's only one ray, so we could say angle B, we could say angle 3, or we could say angle PBS or SBP. And remember that if we use three letters, the vertex is always the middle letter. That's important because that tells us that's the angle. When we measure angles, we're going to place the vertex at the center of a protractor, line one ray up with the 0 degrees, and then state the measure that's at the second ray. We do have to pay attention that protractors have both the acute and obtuse measurements, so we got to think about what type of angle do we have. So, and when we do that, we're going to say the measure of angle and then label that angle as it is. So if we have the measure of angle GHK here, we know that we take a protractor, put H, in this case we'll do HK along the part that measures to 0, and then look, well, where does our other measurement come up to? And we go 0, 10, 20, 30, 40 degrees. And that's an acute angle. I can look at that and tell that has to be an acute angle, so we'd say the measure of GHK is 40 degrees. Now, when we measure angles, we have four different types that are possible. An acute angle measures less than 90 degrees. A right angle measures exactly 90 degrees. An obtuse angle measures greater than 90 but less than 180. That is important because if it is exactly 180 degrees, we call that a straight angle. Now, just like we had segment addition postulate, we also have angle addition postulate, where we know that if we have a ray interior of an angle, we can say that the two smaller angles are equal to that entire angle here. So if we said that the measure of angle BAD is 35 degrees and the measure of angle CAB is 80 degrees, and we want to know, well, what's the measure of angle DAC? Let's label the parts we have. We know that this angle BAD is 35 degrees. We know the entire length, CAB, is 80 degrees. And we know that the sum of these two smaller angles has to equal this entire angle. So we can set that up and substitute in our values. And we can say that 35 degrees plus the measure of angle CAD has to equal 80 degrees, which then tells us that the only possible value is 45 degrees for the measure of angle CAD. Now we can also have angle bisectors just like we can have segment bisectors. An angle bisector is a ray that divides an angle into two adjacent angles that are congruent. And we'll use curved marks to show that congruence. And we have to have the same number of curved marks to represent two angles being congruent. So say that we had an example where ray WX bisects angle VWY. And we know that entire measure is 104 degrees. And we know, well, what's the measure of XWY? So let's draw that. We have the larger angle, VWY, and we know the entire length is 104 and that WX is bisecting it. So there's our entire length, and we know the bisector means these two pieces have to be congruent. So if I think about segment addition postulate, I know that this angle plus this angle's measure has to equal the entire angle measure. But since they're the same, if I label one as X or some unknown, the other one is also X or some unknown. So 2x equals 104 degrees, which means each of those angles has to be 52 degrees, which means that XWY is 52 degrees. Now, if we're looking at vertical angles, we're going to then say that we're looking at the opposite angles that are formed by two intersecting lines. And what's important is that vertical angles are always congruent. And that's going to be helpful. And if we take those four angles formed by those two intersecting lines, we know they have to sum up to 360 degrees. So here's an example where we can see that if we draw in our intersecting lines and we measure this as 70 degrees, this one has to be 110 degrees, and then this has to be 70, so this has to be 110 as well. And we could say that the measure of angle LMR and the measure of angle PMK are vertical angles, so they are equal in measurement. And then the same thing for LMP and RMK. Now, perpendicular lines are two lines that intersect at a 90-degree angle. And we're going to use that right angle, that little box in the corner, to represent that they are going to be a right angle when we have an image. When we write it out with two segments, two rays, two lines, we use the upside down capital T to represent perpendicularity. So if I look at this image, I can say, oh, there's the little box in the corner where two lines are intersecting. So I know then that line BC must be perpendicular to line DE. So all four of those angles would have to be 90 degrees. So some other relationships are important to recognize. If we have adjacent angles, these are two angles that share a common side or a common ray. Complementary angles are two angles that measure to 90 degrees, and they don't have to be adjacent to one another. Supplementary angles add up to 180 degrees. Again, they don't have to be adjacent. Whereas a linear pair is two angles that are adjacent and are supplementary. And it's exactly two angles to do that. So let's look at some examples here. Say we want to determine AZN and we want to determine the measure of JZL and the measure of angle LZH. And we're going to have to use all the different pieces here to help us out. So if we look here, we have that FH is perpendicular to AL. And because of that, and because LZH is a vertical angle to FZL, we know that LZH, that angle measure, has to be 90 degrees. There's no other measure it could be. Now, say we want to look then at NZH and AZN. So AZN is up here, and we know that NZH, they have to then be complementary because each of these larger angles, HZA, has to be 90 degrees. So their sum has to be 90 degrees, which means AZN must be 35 degrees. That's the only possible option. Last thing then is, well, what's JZL? What we should notice though is AZN and JZL are vertical angles to one another. And we know that vertical angles are congruent. So the measure of angle JZL must also be 35 degrees.